Alright, this is going to be a quick little video showing you what the law of sines is for a non-right triangle. So we label the sides relative to the capital lettered angles. And where the law comes from is by finding the altitude of the triangle H and rearranging for each little half right triangle and then setting the heights equal to each other. What this lets you do is it creates a proportion of side B over sine of angle B equal to C over sine C. And notice I had to put in a C there. I made a mistake, so the red C is the correction. And we can show this for any A, B, C up the top there, basically that the sine of an angle over its side is equal to the sine of some other angle over its side. So seeing an example will show us how this works. So for example, let's say we knew angles C and B were 55 and 44, and we knew the length of little b was 9 centimeters. Now, if it asks you to solve a triangle, you're basically being asked to find the other angle and the other two sides. So the first thing we can do is label what we know, and what we're going to have to do here is try to figure out what the length of side C is, because it's across from the angle, one of the angles that we were given. So we plug in what we know, and we basically rearrange this little set of fractions and solve for side C. If you type that into your calculator, 9 times sine 55 over sine 44, it'll give you about 10.6 centimeters. So now we know that side. Now you can always find out the third angle of a triangle by knowing that the three angles add up to 180. So for example, angle A we know is actually 81. And now because we know angle A, we can use the sine law to find side A. So in green here, we'll figure out side A. So A over sine of its angle, 81 degrees. And it's the same proportion as before, 9 over sine 44. Rearrange this formula for A, plug that into your calculator, and you should get a length of about 12.8 centimeters. And one thing to point out is that the longest side corresponds to the biggest angle, and vice versa. Smallest side is with the shortest angle. Now we've solved the triangle. We have three sides, three angles. That's all we had to do. And there's the shortest side, it's side B, and the smallest angle was angle B at 44 degrees. Notice too that we can flip this ratio and put the sides on the top, angles on the bottom. As long as they're consistent throughout, that works. So here's another triangle we could solve. This time we have two sides and one angle. So we'll label what we know. We know side C is 20, we know side A is 25, and we know angle A is 85. So I'm going to set up a little grid. We're going to find the missing pieces. So first thing I'm going to do is try to figure out the angle C. I can do this by using the sine law. Notice if I'm looking for an angle, I have to use second sine when I rearrange this formula. And you type that all into your calculator. Oops. There we go. It should give us, there we go, an angle of about 53 degrees. So now we know angle C. Because we have two angles, we can find the third one, because we know they all add up to 180. So you take them away from 180 to get 42 degrees. And lastly, now we can find side B, because we can put it over sine 42. Whoops, you got to correct that. We want to use, there we go, 25 over sine 85, because we knew the information about A and sine A. Rearrange the formula, solve for side B, which is shown by lowercase b, and we'll get around 16.8 centimeters. And once again, it's a good check to just know that the longest side goes with the biggest angle. And we're done solving the triangle. So, thanks for watching.